before.
Yeah, it's not clicking.
Right. Probability is a measure for how likely a random event is to occur. How likely something is to happen. There's a 40% chance of snow today. So
It's 100% chance.
4 out of 10 times, you're going to see snow. Probability is measured as a value between 0 and 1, or 0% and 100%. If the probability is 0, is it going to happen? No, it's impossible. It will never occur. If the probability of an event is 0 or 0%, it's impossible. On the other end of the scale, if the probability of an event is 1 or 100%, it has to happen. It's certain. There's a 100% chance of snow today. It's going to snow. Some notation on the bottom corner here. I label the probability of event A using this notation, P of A. The probability of some random event A is given by P of A. That is notation for the probability of A having happened. If we know what event A is, we could describe its opposite or complement by using this notation, A of C. This is read out loud as A of C. It is the complement or opposite of a given event A. So if I describe event A as it will snow, what is the complement or opposite of it will snow? It will not snow. Event A is some given random event. A of C is its exact opposite. Wonderful. Some rules on probability down below. The probability of an event A added with the probability of its opposite has to add up to 1. If I combine the probability of one event with the probability of its exact opposite, does that just describe the full set, the full 100%? Now I can also rearrange that formula and solve for the probability of the complement. The probability of the opposite of A is 1 minus the probability of A. If there's a 40% chance of snow, what's the chance it will not snow? Its opposite. 60%. Because didn't you just take 100% minus 40%? The probability of not snowing is 1 minus the probability of having snow. 40% chance it's going to snow. So the exact opposite, there's a 60% chance that it won't.
Slow down.
Slow down.
Slow down. I know that the probability of everything paired up with its opposite has to make the full 100%. The probability of an event added with the probability of its opposite has to make 1 or 100% because it describes everything. The probability of everything is 100%. All possible events have to add up to 100%. So say, for example, there's a 40% chance that it will snow. What's the chance that it will not snow? 60%, because you're just taking 100% minus 40%. To get the opposite, just take 1 minus what you know for a given event. Solve for the other part. We have different ways of describing probability by using probability and what are called odds ratios. I have those formulas over here on the board. Probability is all the favorable outcomes, the number of favorable outcomes, divided by the total possible outcomes. All the different events where I want to have happening, divided by the total number of events possible. Flip a coin. What are the two possibilities? Flip a quarter. I can either get 1 or 1. Heads or tails. So the total outcomes, the total number of outcomes when I flip a coin would be 2. What's the probability of flipping the quarter and getting tails?
50-50.
Because how many outcomes are tails when I flip a coin? Only one of the 2, right? Favorable outcomes, there's one way to get a tails, divided by the total possible outcomes, the 2 sides of a coin. Probability is found by taking all the favorable outcomes, what you want to happen, by the total possible number of outcomes in general. Down below, we have formulas for odds ratios. When I walk into Prairie Meadows and I want to place a bet on a game or some sporting event, typically they give me the odds. So here's a little bit more information on odds. The odds for an event describes all the favorable outcomes compared to the unfavorable outcomes. Favorable to unfavorable. What you want to happen divided by what you don't want to happen. What's left over? Odds against is just the reciprocal or opposite. The odds against an event happening is the unfavorable outcomes, which you don't want to have happen, divided by the favorable outcomes, which you do want to have happen. Rather than using the total possibilities, odds ratios just lists either favorable to unfavorable or odds against, unfavorable to favorable. Let's come back here and look at what's on the other board here. Shayla, can you move your bag real quick? Okay, so what we're going to try today is some given probabilities and odds using cards and dice. Not everyone has the same amount of exposure to cards in a deck, so let's just talk about what kind of cards are in a standard deck. How many cards are in a deck in total? 52. We're not going to include the jokers. 52.
Oh, okay.
52. How many different suits are in a deck? 4. Those 4 suits, 2 of them are red, 2 of them are black. What are the 2 red suits?
Hearts and diamonds.
Hearts and diamonds. Hearts and diamonds. The 2 black suits, the other 2 suits would be
Spades
and clubs. And I've got all those different cards outlined. What's on the backboard here? This in probability is what is called the sample space. It's all the different outcomes put together in some diagram or picture. It's the sample space of all the different cards you could potentially draw from a deck. Half the deck is red, hearts and diamonds. Half the deck is black, spades and clubs. In each of these 4 suits, there are different numbered cards. Ace through 10. Ace is worth 1, 2 is worth 2, 3 is worth 4, and so on. We have ranked or numbered cards. Ace through 10. We also have face cards. What are the face cards? Queen and king, the cards that have pictures on them, right? People on them. There are 3 face cards per every suit. So how many face cards are there in a deck of cards? Well, because 4 suits, each with 3 face cards, make 12 in total, right? How many cards are there in a deck? I'm sorry, not cards. How many cards are there per suit? Or 13, Chip? Okay, well also, how many cards in a deck in total? There's 4 suits, right? So what's 52 divided by 4? 13 the same way. Okay. Kind of a brief rundown on decks of cards, because not everyone has the same familiarity with cards. We also have this table. If you haven't already, I would probably copy this down into your notes, because it's going to be a nice reference table as we're starting to look at different probabilities and odds over the next couple days this week. I roll 2 dice, and I take the sum of the faces of those 2 dice. I add up what I roll. Here is the potential for the sum of the two dice that I've rolled. Dice 1 down this column, dice 2 across this top row. I would. So I don't have to look back up here every single time. I'll leave it up here, but put it in your notes. That way you have it when you want to reference it. Okay. What happens if you roll a 1 and a 1? What have you then rolled? 2, because 1 plus 1 is 2. No, it's neither. Well, it's kind of like an addition table, but you're just adding the column with the row. One dice shows a 2, one dice shows a 1, so I've rolled a 3. What is the most common number to roll? What are you most likely to roll when you roll 2 dice? What number shows up there more than any other? 2, not 8. Look at that diagonal. From the bottom left up to the top right. There are more ways to roll a 7 than anything else. There are 6 ways to roll a 7.
Yeah, it was 1 off.
1 and a 6, 1 and a 6, 2 and a 5, 5 and a 2, 3 and a 4, or 4 and a 3. There are 6 ways to roll a 7. When I say doubles, what does that mean? If you roll doubles, what does that mean? Like in Monopoly, you roll a doubles, you get to roll again. So what does it mean to roll doubles? You roll 2 dice. If you roll doubles, aren't you getting the same number twice? Like a 2 and a 2, or a 5 and a 5, or a 6 and a 6? Rolling a 1 and a 1. Rolling this 2 is actually rolling doubles. Rolling this 4 here, you do by rolling a 2 and a 2. This is a doubles. A 3 and a 3, a 4 and a 4, a 5 and a 5, and a 6 and a 6. There are 6 different ways to roll doubles down this main diagonal from top left to bottom right. Alright, so using that, let's find some probabilities of our own. Alright, you're going to draw 1 card from your deck. Pick 1 card off the top. What's the probability of getting an ace or a face? Probability is favorable over total. Well, how many total cards are there in the deck? 52. Out of that 52 cards in total, how many aces or faces could you draw? What are the favorable outcomes? How many aces or faces are there? How many aces are there? 4, 1 per suit. How many face cards are there? 12. 3, 4 different suits. There are 3 face cards per 4 different suits. So what is that? 12 here, 4 here. There's 16 cards that are either aces or faces. When you find a probability, you can answer as either a fraction or a percentage decimal. If you're going to answer as a fraction, just make sure it's reduced. What can divide from 16 and 52 evenly? 4?
Yeah.
4 works. 4 divides into 16 4 times. And 52 13 times. 4 out of 13. If you want to make it a percent or decimal, that's about 30.77%. To me, it's more work to find the percent because you have to get the fraction first. But I mean, you do it well, you do however you want to do it. Either way is fine. Let's get a few more here. Probability of 10 or black. How many 10s are there? There are 4 10s. All right. Let me kind of underline those here. We've got 4 10s. 1, 2, 3, 4. There are 26 black. I'll underline those here for you. So is it really just 4 plus 26? Are there 30 different cards that are either 10s or blacks?
No, because we can't count the tens with the
I
blacks.
can't count something twice, right? Brooklyn's noticing, didn't I double count by 2? I counted the 2 black 10s twice. I underlined them twice. I don't want to double count anything. Only count everything once. It's not 26 plus 4. It's 26 plus 2. So how many different cards are either black or 10? Was it 28? It's the 26 black cards in general, plus the other 2 red 10s I haven't already counted up. What does that reduce down to? 7 out of 13? Okay, that makes sense.
How do you know whether to put it in decimal or fraction?
Either one is fine. To me, it makes more sense to just leave it as a fraction, Hallie, because don't you have to type that in a calculator? It's like more work to get the decimal if you want it, but you do whatever you need to do. This would be over 50%, wouldn't it?
Yep.
7's over half of 13. Did a couple probabilities. Let's try some odds now.
Aaron Pollard, please report to the secondary office. Aaron Pollard, report to the secondary office.
So this one says the odds of drawing either a 6 through 10 or heart. 6 through 10 or heart. Remember, odds is favorable over unfavorable, listing all the favorable outcomes to all the outcomes that don't include what you want. Not drawing a 6 through 10 or heart. Well, let's see here. Hearts would be this top row. All 13 hearts. Or what else could we have drawn? Six through 10. Do I want to count the 6 through 10 that I've already counted up in the hearts row? No, so just underline the other 6 through 10s across the 3 remaining suits. How many different cards did I underline here? This is 1, 2, 3, 4, 5. That's 5, 10, 15. Plus the 13 on the hearts row on top. How many cards is that? 28. So 28 to what? How many cards did I not underline? How many cards are not hearts or 6 through 10?
24.
How'd you get 24 out?
Oh, I did 52 minus 28.
So when I write it as an odds ratio, favorable to unfavorable, there are 28 cards that are either 6 through 10 or heart. If there are 24 cards or not.
What?
Let's reduce down that ratio. What can I divide 28, 24 both by?
4.
4 again, so what is that, 7 to 6? For every 7 times you draw a 6 through 10 or heart, there will be 6 times that you don't. That's kind of what that means. For every 7 times you draw a card and get 6 through 10 or heart, there will be 6 cases where you don't. odds against spade or face. Space or face. Oh, spade or face. How is odds ratio against different than the odds ratio we just did? An odds ratio against some event isn't favorable to unfavorable. It's the reciprocal. List all the unfavorable outcomes first. When you go to a casino, typically they give, this is the odds ratio they give. It's kind of standard form to give something in terms of the odds against. I think the Kentucky Derby is like this weekend. If a horse has a 5-to-1 odds ratio of winning the Kentucky Derby, they'll win it one time and lose it 5 times. For every one time they win, there'll be 5 times where they don't win the horse. Typically, odds are given as odds against an event happening. All right, spade or face. I'm gonna grab this blue. Let's count up what's gonna happen here. Spade or face. How many spades are there?
13.
13. I also could have drawn what? Besides a spade, I also could have gotten a face card. Do I want to count the face cards that are already spades again? No. So I'm just going to underline the face cards in the other 3 suits. So I've got 3, 6, 9 with the 13 spades here. How many cards are either spades or faces? 13 plus 9 makes 22. Sure. So if that's what I do want to have happen, I put that at the end. I list the favorable outcomes second. If there's 22 cards that are either faces or spades, what are the remaining cards that I didn't underline? How many are not? 30. 30 to 22 can be reduced down by 15 to 11. You're not going to draw that type of card 15 times for every 11 times that you do. How are we feeling here? Okay. Let me give you some dice examples to work on. I'm going to put a couple questions up on the board for the dice table. Well, let's see what your thoughts are here. Give you guys a few minutes to work on some dice practice. Roll 2 dice. And take the sum. Find each probability or odds here.
Can I get a bathroom? My child.
Your child is wonderful.
Okay, I got a handful there on the board. With the table in your notes or the table on the board to the side, find each probability or odds ratio given. Let's let me try the first one together. I'll leave you the other 4. I roll 2 dice and I take the sum. You can sit on that little corner table for me, like to think. Sum of less than 5. Less than 5 means I could have rolled what? See? Well, I can't roll 1. I roll 2 dice, so it's got to be 2 through 4, right? So this 2, these 2 3s, or these 3 4s. To roll less than 5, you could have rolled either a 4, 3, or 2. How many different outcomes did I underline? 3 plus 2 plus 1. 6. Out of how many outcomes in total we're back to probability. So it's the total favorable outcomes divided by all the outcomes in general, the total number of outcomes in general. We know it's going to be 6 ways to roll less than 5 out of how many different ways to roll 2 dice in general? 36. 6 out of 36 reduces down to 1/6. 1 out of 6 chance of rolling a dice and getting less than 5. Rare, but not out of the realm of possibility. You've got 2 more probabilities and 2 more odds to look up. What's the probability of rolling a double? Probability of getting doubles or greater than 9. Odds for a sum of less than 8, and odds against rolling either a 3 or 10. Take about 2-3 minutes here, and then we'll talk about your work.